Guess we're going to find out. Okay, this is number 4. I'm going to talk about CatsPaws and VanNorman and my PK447s that are supposed to be a VanNorman clone. There it is. This is actually gear teeth. It goes into a circular screw mechanism. And as it turns, it moves them in and out. Now, how does that work? Well, that's number 4. And it's kind of hard to see. Oh, very hard to see on that one. There we go. That's a little different. There's number 1, 2. What's this one? There's just a scratch of a difference. So I try and get. There we go. Okay. Now I got to remember where my. There you go. You see where the teeth sit on that one, and here's where they sit on that one. See how far the front tooth is right there against the back. Back here, that tooth is inset a ways. So that's the major difference. And these other two, look how little difference there is there. And that, let's see, number 4, oh shoot, number 3, and I had 1 and 2. Yep. So on these, as I'm facing the bar and the actual bar in front, motor in the back, number 1 is here, 2 is straight out facing, 3 is here, and 4 is in the back. The significance of that obviously is the screw pattern. It's a tube in there with a gear at the bottom. The shaft itself goes through the center, and it's a semi-solid shaft all the way through. It's driven by gear at the top, comes down through, and the head screws on with Timken tapered roller bearing. That's going to get a little bit of clean out and some fresh grease. But these just came in today, and I'm hoping they fit for one main reason. The accessory kit, or I should say the tool kit that I bought, I thought was from India. It turns out it wasn't. It was from China. So it didn't fit well, and when I went to put it in, I gave it a little, not much of a push either, to put it in, and snapped off one of these things. So, knowing what I know now, I'm going to have to get a special diamond sharpening pad to be able to clean the things off and use them at all. However, I do have 3/4 of the original sets that came with it. I don't know why number 4 isn't in any one of the other sets. Go figure. So I'm going to try and get the CatsPaws and the shoes to fit that I have and go from there. Somehow I got to make this puppy work. It's too important to be able to take an antique tractor and bore things. And I did it once before, and it was funny because a customer brought a block in, nobody wanted to touch it. And I think what it was is that John Deere block needed an insert at the bottom, but it was John Deere on some of their engines is inverse. The O-rings are in the block. Well, the block rotted. It still could have worked. That's the weird part. But they wanted it. Okay, so I said, well, I'll take a stab at it. And so, well, if nobody else will do it. So if it doesn't work, then, I'll have to figure something else out. Strangely enough, it worked out perfect. I was in shock. I took that PK447 that I had. Of course, that one came brand spanking new. And you're talking almost 30 years ago, 25 years ago plus. And the accuracy was insane. As long as I had that, the micrometer calibrated to the cutter head, it was absurdly accurate. So I had a lot of fun with that. I mean, it wasn't even a thousandths difference. If I wanted to cut 1/1000th off the inside, I cut 1/1000th off the inside almost. I mean, it was ridiculously accurate, and I loved it. But these were the key. They weren't just centering CatsPaws, as they call them. They're 4. 3 probably is more accurate, but these guys had 4. And just a little bit of, when you dial them out, there's a torsion bar in the upper knob that turns the tube to run these out. And it hits, and then you flip it over and click, 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 just a few clicks to give it a little spring pressure. Well, then the head stays more stable, sliding down through the bore. Much more stable, shockingly stable. So, and how do you center it? Well, to begin with, you set your boring bar up there, run it down in the bore. You've already selected your end cat's paw, what would you call them? The feet, and you run them out into the bore, and that's how you set your boring bar up. You get it into a clean part of the bore, usually halfway down or a little further. You run the thing down in there, open the paws up, and you can actually see the bar move around. Give it a little bit of a wiggle. Final couple of clicks on the spring snug, and then lock your base down, which is usually just a T-bar that goes down through and hooks in to another T-bar in the main bearing saddle. So they do have another one to lock it in the cylinder bore itself, but every one I've used actually locked into a bar into the main bearing saddles. No, that doesn't center it to the main bearings. It just holds it there. And I did it on one of them. I had to do it across the oil pan rails. All it needs is something firm to hold it in place. And the John Deere, I bored it, but it was hard because you need to know where the O-ring grooves are at the base, and you need to know where the top of the insert's going to be, and you need to line your O-rings can be off, probably 10 thousandths one way or the other. They don't care, really. There's enough metal at the bottom. The problem is the crevice seal. There's one that goes on the sleeve on the outside, and there's a shoulder. And when it comes down in, that crevice sleeve has to hit that shoulder. Well, I had to hit that dimension. Apparently I did. Didn't see the black back. So, and even there you could be off by 5 thousandths or so, and it would be hard to hold it in place, but at the same time, it would be fine. So when I got done, I was very happy. I was just, and if there was a problem, you take the boring bar down in there, and if the upper part of it's usually fairly thick, so you shave it off. Yeah, there's a right angle cutter that actually has a taper. Well, let's do it the other way. The taper and then the cutter. I don't know how to, my hands just don't work that way. But anyway, it has a flat spot in the cutter, and then there's a taper here, so it comes to a point. And this bottom edge, the side, goes around and just shaves it right off. And it'll make, because of the point, it'll make a square corner. And if you don't like that, well, you take it up top and you round it off a little bit on the sharpening wheel, and round it off, make a radius, and go down in there and do it again. But usually we're looking for something akin to a fairly square corner. So especially on inserts, similar to your valve seat inserts. You're looking for a minor radius at the most, because valve seat's chamfered, but it has to sit in there as much as possible contact area. So, but that one Deere I did, I can't remember if I did all 6 holes or the back 2 or 3. I just don't remember. But that's what the crevice seal is supposed to prevent, is anything getting down in there between the first O-ring and the sleeve, and crap sitting down in there and getting down in and eating it out. Well, if it doesn't, then it starts to eat it, and it'll go down in there anyway. But it takes longer. So no, Cummins used a crevice seal. In fact, they had some of them that used a crevice seal and the actual steel of the sleeve, mid-stop liner, to seal. It worked. Cummins did some scary stuff. I mean, stuff that they should have been shot in the foot for. And it worked. That's the sad part. The ISX, the ISMs, they did some... The L10 engine was a research and development engine. Literally. It was its own bird compared to any other Cummins of the day. It's just its own thing. Then the C series was another offshoot of the L10. Mid-stop liners, higher horsepower. And what's the idea of the mid-stop? You got all that tail down in there. Well, yeah, but the mid-stop brings it up, so the center of the sleeve, where a lot of your pressure is going to be, and the vibration, when the piston and rod are at their angle, that's where the sleeve is going to be most solid in the block, is what they're hoping, so that the sleeve isn't flexing as it goes up and down under high load. because Cummins was trying to do a or as long a stroke as possible with the shortest rod as possible. They were trying to run a square engine, essentially. And if they had a short rod, they could bring the deck of the engine down. One of the problems that people had with the old 855s and the previous NH engines, the 743s, was it 740 or 8 something? Yeah, it was 743s, and then the later 855s. The block was tall. I mean, really tall. You had a 5.5-inch stroke, some astronomical stroke, but they made sure there was a long connecting rod. And because of that, the pressure on and angularity of the rod and the pressure on the skirt was so low, they could run those things up 2600 RPM, where your short rod engines, ISM, ISX, QSM, QSX, and your ISC, or QSCs, the shorter rod, shorter block, everything's short, so there's a lot of stress. And you notice that their average RPM, or rated RPM, is 2,000. And they don't want to rev over 2200. And it's because of that rod and angularity. It's a heavy rod. So, but anyway, that's the CatsPaws. That's hope if they fit the way they're supposed to, because it did come from India. It's probably from their factory or something similar. And I mean, probably over in their part of the world, these things are all over the place. And if that is the case, then these will be a perfect fit in that boring bar, and I'll be underway. Still has some problems. It has grease that has to be changed. Service that's never been done. It sat for years. Moisture got in there and kind of scuffed up the bar some. So it's not going to be ideal. It'll be for, basically it'll be for a street engine or antique work. And that's about it. Now, the funny part about antiquing is that if I played around with an idea and figured out how to do it, I could actually and literally put a main bearing cap on an engine with this boring bar on some engines. Mount it to the top, set it down in, lock it into one of the bores, good bores, set the cutter, put another cap on the other one, run it down through. It is possible. You see, oh, wait a minute. I can't use the CatsPaws when I put the sleeves in the bottom of the deer block, so I made light cuts. If you use your head, there's a lot of stuff you can do with these things. But there again, there's some of you naysayers. You're still correct. It is not designed for that. Well, anyway, I'm just past 13 minutes, and I figured I'd stop in here and say I finally got my parts. And I ordered them off of eBay week and a half ago about, and I ordered another set by accident. I thought I hadn't ordered these. I had to put them on the credit card. It was an astronomical price. It's probably not out of line, but I ordered the ones that were, and then they come through labeled VanNorman, labeled from Delhi, India. Yes! I'm hoping they'll fit. They went up as high as almost $400 for a set of these. Got these just under $3. By the time they got shipping, $350. So I'll be paying off my credit card forever. But there's a couple of John Deeres out there that I may need to bore later. And it's one of those things where if the tractor runs that good for that long, I may be able to end up with a job to bore that engine. That would be fun. Anyway, but it runs now excellent, so we're not going to see any boring work in that. No, it runs too good as it is. A lot of blaster, a little bit of Marvel Mystery Oil, a lot more blaster, clean up the bore, a lot more blaster, clean up the bore, more blaster, clean up the bore, run the pistons up and down, clean up the bore, more blaster, run the pistons up and down, clean up the bore. Do you get my drift? Just keep soaking it down in there and soaking, even while we were working. Pulled the head off, redid the head, put it back on. New way valve seat stuff. All the way, baby. Is it perfect like some of these new 3-angle, 5-angled? No, it's not. But is it perfect for what we're doing, what I'm doing? Not even just for antique. I'm talking your diesels on the street and on the road. Yes, it is sufficient for all of that. They're talking runouts of 1 in 2,000s. Are you kidding? I mean, this thing's right there. So, and guys have drivers for them for the diesel work. I got the hand jobby. Whoop. Don't even fire up the electric motor. If I don't need it, why use it? If I'm cutting valve seat pockets, yeah, now you got to have the motor. Turn it down to about 15, 20 RPM and let it rip. So then that may change too, because that has some a design change I may have to. They have a whole separate foot pedal for running this thing. And I'm thinking of bypassing the foot pedal that's on there and just putting it on the feed. We'll see if any of that works at all, because you got a cord hanging here, a cord hanging there. This is tied off, and I'm thinking to myself, I'm working a unit here 30 years old. It had a major crash one time. It bounced in the air and came down and blew the control box into pieces. And I managed to get it back together, solder a few connections, and get her working again. And it had been working like that for 5 years plus. So, and it's still working good. But I don't have to use it most of the time. And my foot pedal, the beauty of that is to put the foot pedal on. The other one has an on-off switch. Well, use the foot pedal, please. You turn it on, you run your seat, you go to pick it up. Now the cutter comes up, and if you don't grab the cutter while it's slowing down, and you shut it off while it's, you cut your seat, shut it off. It's a fumble. Okay, if you pick it up, you get to the point where you think you want to be and you pick it up, well, now you got your joints, okay, and your seat, the cutter falls down, hits the seat, you got marks in it, and no. The other one's electric. I go grinding, lift gently and let off the pedal, stop. Now I lift everything off of there. Well, I got two pedals. One of them's on my drill press as a safety, because you know how often they catch, and then you're fumbling, reaching. I just move my foot. Unfortunately, the way it is, there's not enough room to rewire it. That shuts the light off too. Okay, now reach up, shut everything off, reset it if you have to, and turn it back on and hit the pedal, and then go down through. Sometimes all I have to do is release the pedal, releases the part from the drill, sets back down, hit the pedal again, and go. I love it. I'm going to have to do something similar on my Walker Turner. I got to bring the Walker Turner up because its accuracy is insane. It's not a radial arm drill press, but it's set up to work similar to a radial arm drill press. And if I can get that on a working table with a wide enough new table, like something that's a 1/2-inch thick steel supported by its main table, I'm looking at something that I'll be able to put heads on and drill studs out accurately. That's what I got the little one to fill in the gap for the moment, and it was like $40 or something. That's all it's worth brand new, but it was new when I got it. Old. When, I think, I can't remember if it's Wen or Dremel. It's one of the cheaper ones. It still works pretty good. But if you want high-speed drilling to sit down there with a 50,000th drill bit, run at that speed, 2,000 RPM, sadly, it'll do it. But if you want to run anything bigger than a 1/4-inch hole, it'll do it. But you better have a sharp drill and know what you're doing. It's it's kind of like running an 18-inch bar on my MS-250 steel chainsaw with a 325 chain. Keep it sharp. You'll be happy. Even partially dull, you'll know. But if you keep it sharp, it'll run as good as any other saw running an 18-inch bar with 325 chain. It doesn't have the power to pull through a dull chain like some do. That's right. That's not necessarily a bad thing. Catch you later.